Hello, everybody. Be angry. Sit down now. Awesome. Well, good evening. Welcome to the Solar Washington General Meeting. Really quick, we have some breaking news. Dave Cozen has stepped down as president, and so we're going to bring David Nicole up as president, and he's going to take over this conversation. But we do have Bill Hoffer with us tonight. So, yeah. And don't forget, we're going to go drink at Finney Market afterwards. Beer.
Thank you. Hey, I'm David Nichols. Some of you probably know me. The only reason Dave Cozen's not here tonight is because he really does have the flu. So, you know, it's a little awkward that I and Wendy introduce myself, but Dave is stepping down because he's got SIW board things he has to do. He's getting married in a couple weeks, so it's pretty hectic for him. I know. What what kind of excuse is that? So, anyway, I've been in the industry for about 4 or 5 years now. I work for Capstone Solutions as my day job, doing solar development there. Let's see. We are going to be drinking at Finney Ridge afterwards. I'm in following in Dave's footsteps. I'm going to mention this a number of times tonight, so make sure to come out. But we're also going to be doing a couple of new things with the board. One of the things we're looking at doing right now, and this is mostly aimed at installers and anybody who works in the industry like manufacturers, is we're going to be sending out a questionnaire followed up by a phone call to everybody in that arena, and we're going to be asking for anonymous data about your company that we can give to the legislature. So we're going to try to support the legislature by saying, this is how many jobs are in Washington State because of solar. This is the average wage of these jobs. And so this is all going to be completely anonymous, but you will be hearing from us pretty soon on this. And we're going to do it either over the phone or through an anonymous survey. We're going to try to work more with the legislature to support the industry. So that's going to be something you're going to be seeing a lot more of. We're also going to try to start turning, we've been discussing at the board, turning more towards doing more Solar 101s and becoming more of an educational group. Since SIW has formed, you know, it seems like it makes more sense for us to appeal to the layman, the person who wants to put solar on their house or on their business, instead of people who are really interested in technical stuff. We're trying to kind of shift our focus a little bit. So you'll see that coming up too. And we will go ahead and report our data that we gather at the next meeting. We're also going to try to put together a recap of the Solar Summit for those of you who didn't make it. So we'll just try to briefly go over next meeting, kind of what happened there and what was said and what some of the interesting events were. But tonight we have Bill Hoffer basically going over commissioning with us, and so I'm personally really looking forward to this. So I'm just going to turn it over to Bill, and we are drinking tonight at the Finney Center. So like I said, I'm going to do that a couple times.
That's the only reason why I'm here. I feel kind of weird with a mic here. I've never done a mic before, so I might forget, and you might have to tell me. Yeah. Right. So I've been in the industry now for 20 years, actually. It was my anniversary of going through SEI's training, Solar Energy International, 20 years ago. So I've kind of seen quite the gamut of how the industry has grown from being kind of mostly fringe hippie up in the mountains of Northern California putting in solar because they're the only ones that could afford it 20 years ago to, you know, today where we're growing into a good industry. And so I want to go over some of the commissioning tools that are becoming available now for installers to use, and we're starting to see them a lot more in really big installations where the banks are coming and saying that they require, or utilities coming forward and saying they require certain commissioning tests to be done before they take over ownership of the system. So that's becoming more common now. A lot of these tools are coming out of Europe because Europe already has these requirements. You can't turn on a system at all without doing certain IEC required commissioning tests to do them. And I want to kind of emphasize industry best practices. I think commissioning and thinking about commissioning is a really good way to bring your installations up a level, to really think about the quality and the installation you're putting in, and having a way of being able to measure it so you can measure your quality and improve over time. So this is a definition, ASHRAE definition of commissioning, and the only thing I want to point out about this is that it's not just the testing, but it's the planning, the designing, the installation, verifying the installation by tests, and then having an operations and maintenance plan to make that system survive and produce for 20 years. Unfortunately, we've promoted solar as a no maintenance, and it really is not no maintenance. It's lower maintenance than like a wind turbine, but it's still maintenance. There's still an electrical system that's out in the weather for 20 years and it still needs to be maintained. And I want to go over some of the reasons and the types of reports that are used for commissioning, and go over some of the standards and guidelines. And I'll talk a lot about the IEC because that's really the only written documentation, that's international documentation now that's available for that. And then the fun part of the presentation will be talking about the toys. I mean the tools. They're toys to me, but when I buy them, I tell my wife they're tools that I need to have for my job, right? I guess it will. So if you could play the video. Why commission? The sound might not be that good. So I don't know if this is a good thing or a bad thing, right? I mean, we're being recognized. The solar industry is being recognized now. That's a good thing, right? Well, we're laughing, but actually there was a do-it-yourselfer that did not attach his system. He just kind of laid it on the roof. And the only thing that was holding it up was the wiring, which eventually failed. It really happened. So even though this is, you know, a commercial, it really happened. So we're going to go right into the reasons for commissioning. I want to go through them kind of quickly so that kind of getting that mindset of why we commission. I think the most important reason to commission is quality control. I mean, it's a way to verify the job that you did and to verify to the customer that you're giving them what you promised them. And you're making sure that it's performing properly, that it's safe, and which is really important, I think, too, is documenting as built, because a lot of times you plan it and you get on the ground and you start installing it and you realize that plan isn't going to work. I got to change it. So it's good to have that documented so that when it comes time later on to go troubleshoot it and try to fix things, you know where everything is. Or as I often get called to do, to troubleshoot systems that have no plan and no design, and you spend hours and hours and hours trying to figure out what the person did before. And I think it's a good method, too, for verifying installation procedures. In this case, this is a Weeb on a microinverter. It really wasn't designed or listed to do this, but we were able to verify the ground continuity with the way that we were doing it. And I think that's a good method, too, for installers. All this new racking and equipment is available out there. You don't really know how well it's working, if it's good or bad, or if it's getting the job done, or it's a hassle to make it work right. A lot of Weebs sometimes are very difficult to line up, and if you don't line them up, you don't have a ground. So this is a good way to verify it. It's a good way to maybe pick equipment, say this stuff works better, this stuff works easier, it gives me better results, and it's less hassle for me. So even though it may cost more, it might be worth it because it speeds my installation up. And I think it's a good way, as we're growing as an industry and you're training new employees, it's a good way to verify that they know how to do it properly and they can actually take a measurement and say, yes, I've got the ground properly done. And I think it's an opportunity to have customer satisfaction, to actually show the customer a checklist. Here's what I do. Here's what I'm going to give you. Here's what you're paying for. And then come back afterwards and show them the data, show them that everything was done the way that you promised. And then they also have a record of it, too. So I think it's a good opportunity for that. And I think it's a service opportunity, too, to come out on an annual basis and just check the system. And I don't really want to talk about this one that much, but having a well-documented system showing that you did everything you were supposed to do above and beyond what is code required, showing industry best practice. If there's ever any legal issues that come up, you've got a document that says you did it right and showing what you did. So I think it's valuable for that too. And it's actually being required in really big projects. And it's very useful to actually get a baseline for warranty data on modules. So the green line is actually would be what the warranty predicts the module to predict. Obviously the red line is not doing so well. It's sliding well below warranty. And the blue line is just an example of a module that had a major failure or a string that had a major failure. It might not have been the module, but it might have been the installation itself that had a failure. And so being able to see that several years out when it starts to trend really bad like that lets you take preventive action to fix that before it starts becoming a huge performance issue. And then this is the one everybody thinks commissioning because banks are requiring it. The bank's making me do it, so that's why we're doing it. And the banks, of course, are doing it because they're putting the money out on the table and they want to make sure that they get return on their money. So a lot of larger projects for financing requirements, they're going to require third-party commissioning. A lot of times they're going to require recommissioning on an annual basis to show that the modules are meeting their performance that they're expected to have. And in some places, you can't even get incentives without having a true commissioning done on it. And then there's several types of commissioning. There's initial commissioning, which would be a startup commissioning where you're actually going in and you're doing the initial startup of a project before you hand it over to the owners. And that's like the full enchilada. That's the whole commissioning where you're going through all the paperwork and going through all the design work and you're making sure that everything was done as was specified to the customer. And of course, in a home system, that's not near as detailed as it would be on a large megawatt system. And then we have what we call recommissioning, which happens on an annual basis, or it comes up because you got some troubleshooting to do, you got something that's wrong, you got a performance issue, you're trying to track down what the problem is. It's already been commissioned once, so you're just going back and doing an annual maintenance checkup, or you're going back to track down a problem. And then the one I really hate is the retro commissioning. That's when someone calls you up and says, it's not working. Can you come and figure it out? Because nobody else knows why it's not working. And that's usually the hardest one because you have no records. There's no records of the initial install. They don't have the paperwork. They don't have the drawings. And so it becomes a real troubleshooting nightmare. And there really are not many guidelines in the U.S. yet. You know, the first one I think should be a company. Companies should have internal guidelines of how they do it and how they commission the system. And of course, we have the National Electric Code and our Washington Code that we can follow, and uniform building codes. And now people are starting to get involved with fire codes. There are starting to be issues now too. So all those things we kind of need to know and be aware of before the commissioning. And some of the guidelines, like the solar ABCs, expedited permit guidelines, are really nice. Sorry about that. Anybody else forget to turn their phone off? Enough of that. And there is actually, IRAC has a field inspection guideline too. That's a pretty good document for going through and figuring out what you need to do for commissioning. And the one that I'll probably spend the most time with is the IEC 62446, which is the PV system commissioning guideline, and that's the International Electronic Council something or other. It's in French, I think, actually. But that's the international standard. And that's the one that most of these tools that have been made that are coming to us from Europe, they've been made to do those specific tests. So that's why I'm going to spend a little more time on them. And in Europe, you can't turn on a system without having a commissioning report where you've done these individual steps. And I won't spend much time on it because I want to get more into the the tool part. You got to watch that. If I say that wrong to my wife, I'm going to be in big trouble. But basically, a true full commissioning means you got to go through all the documentation. You got to go through all the electrical single line drawings, 3-line drawings, all the spec sheets. You got to look at all the wire calcs, you got to look at all the overcurrent protection calcs, and you got to check to make sure that that's all been done right before you even go on the site. And then you have to also check all the mechanical, if you had wind loading or other things, or if you just used the racking manufacturer's recommendations for the racking based on your wind loads, that all needs to be documented. And it needs to be documented in a way that the person that's in charge of the operations and the maintenance can find that material, and he can track down all the owners that did different parts of the work, or all the people that supplied the different parts that are used in the system. And they require a very detailed operations and maintenance plan. Basically, the owner needs to know how to turn the system on. They need to know what it means if the system's working right, how they know, and if it's not working right, they need to know that, and they need to know how to do an emergency shutdown at a very minimum. And even a residential system should give their owners that bit of information. You know, if you see this, call me. If you see this, here you go, turn it off here, make sure everything's safe, and then call me, right? That sort of thing. And then the inspection is just an overall inspection to make sure that everything's matching the documentation and everything's been done properly, that there's good workmanship, and that everything has been done the way it's supposed to be done. And this is all before you even go to the point of starting the testing. So the IEC 62446 requires testing of the PV AC systems. So that's on the grid side of the inverter. And the first one is ground continuity. And that's a pretty important one, because if there's a short, that's what's protecting me from becoming the grounding rod. So, and especially when you're doing these types of tests, because these tests are done on live circuits. You can't do these tests without having the system actually running. So you want to make sure that the ground continuity is good. When it's good, we're happy. And then, of course, you have to make sure you have the right voltage and phase. And the reason for that is, if it doesn't match the inverter, you could have a major problem. And I've seen this happen, actually. I've seen people put the wrong inverter on the wrong voltage and phase, and that's usually not a good thing when you turn it on. And another requirement from the IEC is insulation resistance, which is actually a test to test how good the wire is, how good the insulation on the wire is. If the wire's been nicked in a piece of conduit, or particularly over time, if a wire has a tight bend going into a metal box and they didn't leave enough extra wire for expansion and contraction from heat, that wire can get pinched over time and it'll get grounded and it'll cause a problem. I've done a couple jobs where the utility has required the main feeders to be megged, going back to the panel, which was kind of unusual. And then you got to check your protective circuits, whatever they are. If you have a GFI, you got to be able to show that it was working properly, and you got to show. Now we're starting to see more arc fault required, so arc fault also has a testing circuit, so you can verify that it actually works. And now comes the fun part, the stuff we do on the DC side. So this is a picture training. Was this last year, Kevin? It was over a year ago, wasn't it? We did training with Northwest Wind and Solar. And what we're actually doing is the ground continuity check. We're checking from the array, some surface on the array, either the rail or the frame of the array itself. And we're testing that going back to the grounding system. So we're running a wire from there, from the grounding system to the array, and then we're running it through our meter to get an actual resistance measurement. So this is a little different. On a lot of our meters, we can do a continuity test where we just get the little beep. You go beep, and everybody thinks that's good. I have a connection, but that doesn't tell you the quality of the connection. And you actually have to send some current through to get a good resistance measurement to know exactly what your resistance is. So this is actually a pretty critical step. You can see we have a long spool of wire, so we can actually walk down the array and check different modules if you need to. Most of the time, for commissioning, you might just check the module on the end. And then, of course, we have to check our polarity and string open circuit voltage, which is easy to do with a normal voltmeter, not a problem at all. Some of the tools that I have up here do that automatically for you, which is really nice too. And this is the tough one. This is the one that's required IEC. They want you to do the string, whatever the string length is, they want you to do a short circuit current. And that's pretty easy to do with your meter with a single module if you use these little dummy test leads, because you don't ever want to put your meter, you don't want to do a current measurement with your meter with your probes, because when you pull the probes away, you're going to get a little arc, and that little arc is going to carbonize the connector. And once you carbonize that connector, it's probably going to fail over time. And I have seen connectors in the field that have totally melted. And I'm guessing that was probably one of the main reasons why that might have happened. Could have been a bad crimp too from the factory, but I'm guessing that someone pulled it apart and went, oops, and put it back together real quick before anybody looked. And there you have it. Over time, that gets worse and worse. The resistance builds up. It gets hotter and hotter, and then you have certain conditions. It's going to end up melting. But you can't do that with a full string. It's way too much fault energy to do that with a full string. And besides that, your meter is probably not rated to do it either. So the only real way to do that is with a clamp-on meter. That's a safe way to do it when you're doing string measurements. But then it's hard to get the short circuit current. You can get the current going into the inverter quite easily because you can just do it through the wiring system, but the short circuit's a little bit harder. So the tools from Europe have been made specifically to do those tasks, so they do it automatically for you, which is really nice. And then insulation resistance, which is basically, some people call it megging. I think in the inverter world they call it high potting. Basically you put a high pressure on it, you put a high voltage through the system, and if there's some place where there's a small nick or where it's rubbed up against metal somewhere, it'll flash over and you'll get conduction through that piece, and then that you'll have a very low resistance measurement when that happens. So you're looking for a very high resistance measurement, that all the insulation is in good shape going down through the wiring. It's kind of similar to pressure testing pipes. And that can be done with a normal Megger, off-the-shelf Megger. Basically, you put your negative onto the ground, and you put your positive onto the negative conductor, and then you have to choose a voltage level that you'll do the test at, and it just puts a small amount, a couple hundred milliamps, I believe, into the circuit, and then you can test the circuit like that. The problem is doing it with a Megger is that if I have a string with one module, it's not a big deal, but if I have a long string, then that voltage is going to add in this situation. So if I'm testing at 500, by the time I get to the end of the string, if it's a 600 volt string, I'm over 1,000 volts. And every module is being tested at a slightly different voltage, which is it should be fine. Actually, I take that back. There is a potential issue. I've never heard of any failures when I've talked to anybody about it, but it is a concern. If we did have a short on this guy, say we had a positive short right back to ground, and we did this at 1,000 volts, then we could be subjecting a module that's rated at 600 volts to 1,000 volts. And if there was a bad diode or there was a shading issue where a diode was being fired, you could potentially damage the diode, because the diodes are rated at about 45 volts. It's the International Electronics Commission. Well, they're not requiring it in the U.S. This is a recommendation in the U.S. So there's a way to do this safely, and that's what I'm going to get into a little bit later when we talk about the tools that they have. So, I mean, the best way to do this actually in the way that it's done by the module manufacturers is they short the leads, and they put the positive conductor on the shorted leads, and they put the negative conductor onto the frame, and they test it that way. So that way there's no difference in voltage through the modules. There's no chance of damaging the diodes, and there's only a difference between ground and the two shorted leads. But in order to short a string, where you might have a 600 volt string, you have to have a special arc flash type of switch that can handle that, doing that over and over again. So that was a good point, actually. And then the final thing in testing is just to make sure that everything's working, make sure that the inverter shuts down when the power goes off, make sure that the ground fault is working. Basically, that's pretty easy to do. You take the ground fault fuse out and you start the inverter up. Shouldn't start, right? And then if there was arc fault, we'd have to do a test on that too. That's coming sooner or later. And so for performance testing, you really need to do, you have to know what the irradiance is, and you have to know what the cell temperature is so that you can back out the STC values of what the module is supposed to be producing at standard test conditions. And without those two tools, this is a little, actually I have one up here too. It's just a little point. It's kind of like a thermal camera, but it only has one pixel. It only does one little dot to measure the cell temperature, and you need to have a way of measuring the irradiance so you can back it out. And a lot of these tools, these special tools that I'll show you, they have that all built in, so you don't have to worry about it. And I don't know if you can see very well here, but actually they also have the C word. When we look at it, also you can actually measure the kilowatts going in, and I don't know how well you can see it right there, but it's actually giving the kilowatts that the array is producing right at that time. Can we turn off this front light? Yeah. Oh, does that help a little bit? Yeah, so right here it's actually giving the kilowatts because I've got the two probes on the positive and negative, and then I have the clamp on. And that's really convenient because you can get that reading instantaneous. And with this device, you can also be recording the irradiance and the temperature at exactly the time that you do the measurement, which is really helpful. I don't know anyone who's done a performance validation by having 3 meters and 2 clamp-ons and trying to record everything instantaneously. It's not as accurate, for sure, especially if you're, which is usually the case when you're commissioning. It's never a nice, perfectly clear day. Sun's just where it needs to be. There's no clouds. There's no wind. So conditions can change pretty dramatically, especially in these larger megawatt systems where they're having to test lots and lots and lots of these. So the nice thing about that is that you can actually, with one of the other tools too, we'll talk about a little more when we talk about the tools, but you can actually get the, AC, you can get the efficiency of the inverter, and it'll calculate it automatically for you, which is really nice. So believe it or not, the IEC says torquing is optional. So definitely in initial commissioning, you would do torque checks, make sure everything's been torqued to the specifications. And sometimes that's a random test, or sometimes that's each piece has to be torqued, and they want a record of each one in each device when they start out. But what's happening nowadays, a lot of people are using infrared cameras after that initial test to go back for their annuals, because they can take an infrared picture and they can see if there's a loose connection because the wires are going to be running a lot hotter. And that way they don't have to retorque them every time. And a lot of times maintenance plans will actually be based on what the temperature difference is. A certain temperature means, okay, whenever the maintenance guy gets there, have them check this one. Or if it's a higher temperature, they go, oh, this is really hot. We need to shut this down. We need to get somebody here to fix this right now because this is way too hot. And it seems like everybody goes towards the really high-tech kind of cool tools, although I don't really think that you need them that much unless you're required to in like a commissioning of a big bankability project, a megawatt project. They may actually require initial curve tracing of all the strings in the system. In fact, I have a couple friends that are going out and they're doing a big 50 megawatt sun power project, and they're going to curve trace every string after the installation. So some banks are starting to require that. So is everybody familiar with the IV curve trace? This axis is the current. This axis is the voltage. And basically an IV curve tracer makes the module go through all of its different iterations under different conditions of how it would be operating. So this is the same thing that the manufacturer does when they get a curve traced to tell you what's on that sticker and what the specification on the module is on the back. That's the same way they do it. They do it artificially. They do it at standard test conditions, which were basically indoor temperatures done in the factory floor, which is convenient. They don't have to worry about the sun or the changing cell temperature. And that's why we need to be able to measure the cell temperature, and we need to be able to measure the radiance so that we can back it back to that standard that they have it at. And the other thing the curve trace gives you, it'll give you a maximum power point, which is kind of the knee in the curve. So that usually ends up being right around in here. So if you have your ISC and you have your voltage and you've done your performance validation under operation, you've got 3 points of that curve. So you've got most of the curve. And if there's something wrong, you're going to know right away when you do the performance validation. So in my opinion, you don't really need a curve tracer, although if you do have problems, a curve tracer makes them a lot easier to track down. And IEC says curve tracing is optional. It's not required. And an infrared camera is more or less a troubleshooting tool when you have problems. In this case right here, that cell is actually a shaded cell that's hot right there. And that's why it's so hot. It's actually dissipating energy from the rest of the module. And it's not enough energy to fire the diode, but it's enough energy for it to be quite a bit hotter. So it's running at about 10, 15 C hotter, maybe. And here's a picture showing a loose connection in this lug. And it's kind of interesting. The lug doesn't actually look hotter, but the wire looks a lot hotter. And sometimes when people look at this, they go, well, that must be a smaller wire. That's why it's so hot. But actually, it's the same size wire. It's just that the connection is very loose. And this is one that we purposely did in a lab yard to have people identify at SEI. And talk about electroluminescence a little bit. This is where you actually turn the module into an LED light, but it's at a frequency that we can't see with our eyes. So you need a special camera that can see it. And it used to be very, very expensive, $100,000 camera. It had to be done in a black room and everything else to make it work right. But now we're starting to see where you can do it actually in daylight conditions. And they're starting to make cameras now finally that you can actually go into the field and do this. They're still pretty expensive, but they're dropping in price pretty amazingly. And actually we had Fluke came out and did some, showed us their new camera at iTech, and we talked to them about putting electroluminescence into their IR camera, and they said, oh, that might be a good idea. So maybe we'll even see something like that eventually. So basically, under that special camera, you can see the lighting conditions, and then you can see these dark spots. The really dark areas are places that aren't conducting for whatever reason. There's a crack in the cell, or there was a bad solder, or there was bad finger contact. They didn't do a good job with the fingers, something like that. And here's what one looks like after you walk on a module. Some pretty major cracks and incontinuities in the module, right? So everywhere it's dark, it's not able to conduct, and it doesn't light up like an LED. So it's actually pretty revealing. So toys. So in general, everybody should have a multimeter and a clamp-on. I wanted to show this particular clamp-on that actually seaward sells. It is actually a kilowatt meter. So if you attach the probes and you put the clamp on this guy, you can measure directly the watts that are being produced on your system. And that works really well in combination with their other tool, because you can see the DC kilowatts on that one too. So then you can actually do your performance validation. You can see your watts in and your watts out of your inverter. Better than having a clamp on and or guessing what the voltage is, or having a meter on too. So this, I think, is a great tool, and I use this probably more than almost anything else, because it's just so simple, and it does AC and DC, and it's only, I think, $450 or $500. And I tried to see if I could find any American-made product like that, and the only way you can get a product like that is like you get the 3-phase analyzers from Fluke, and they're like $10,000 to $15,000, about $500. So that's a really sweet tool. I use that almost more than anything else. So I wanted to definitely bring that one up. And everybody in their toolbox should have a little pyranometer so they can see what the irradiance is when they do their test. Absolutely essential. Some of these tools come with them, and some of them you can use to do manual measurements. You don't have to use them with the tool. I forget the brand this is. Is that a Day 4 or a Daystar? Daystar, yeah. And then you need a way of measuring the cell temperature. And this is just using one of the standard little probes that come with your meter for doing temperature. But the hard part is, of course, if you hold it with your finger on the back of the module, you're going to measure the temperature of your finger, which is not going to give you an accurate measurement. And it's not the best way to measure it, the back of the cell, but if that's, that's the minimum way that you should try to do it. You can certainly use these guys and do several point measurements and average them. That's a little bit better. The more points you get, the more data points you get, the more better the average will be. And you can also use your infrared camera to do it too. And it can do an average of the entire module. That's another way to do it. And some of the meters, I believe Solmetric and the IV curve tracers from Huxaflux, they actually have an algorithm that they'll measure with their little sensor cell that they have mounted up to do the testing. They'll measure the temperature of that sensor cell, and then they'll back it out based on the module's NOTC, which is probably the most accurate way to do it. Because this is a calibrated cell, so they know exactly what it should be producing at a certain irradiance and a certain temperature. So they can do a little algorithm to back that out. Torque wrenches. When I do commissioning, I like to use the one with a gauge, because I can see the torque that's happening instead of the click torque. And I can also take a picture of what I tested it to validate that I actually did it. And then they have small little ones for doing your small electrical connections too. There's several different styles of this too. And then of course a digital camera. Lots of pictures, lots of pictures. Cheap now to take lots of pictures, right? It's the best documentation you can have. And in some cases, you might need an inclinometer or a compass to verify that the orientation of the roof and what the angle of the roof is. In some places, they actually require you to do like a Pathfinder or a SunEye, where you actually document exactly what the shading issue is on that roof. And in some places, they won't even give you incentive payments unless there's a minimum amount of shading. So that's not something that we have to worry about that much here, but it is something good to document. Because if you have a different performance than what you expect on a certain site, that might be one of the reasons why you have a lower performance. The other site might have a better orientation. So ground continuity. This is an interesting one too, because the tools that do the automatic, they do all the testing together. The combination tools are really nice because they do ground continuity. I couldn't find any really good ground continuity testers. Most of the testers that are out there are testers that test your ground to make sure you have a good solid ground, and they're expensive tools. Now, there's a couple I saw that were like little clamp-on ones, and I think they send a little signal up through the wire, and somehow they measure the resistance in the wire by doing that, and I've never used those. I don't know how well they work. Those are the ones that are in the $800 range. And then you get into the actual ground testers. I mean, it's like the inspector says, if you can show that your ground's good, you don't have to use another ground rod. Well, the tester costs $12,000, so how much does a ground rod cost? That's easy. I'll just put another ground rod in. I'm not going to buy the tester, right? So it's nice to be able to confirm that your ground, you have continuity from, we have a pretty complicated grounding system. We have a lot of different connections in it. And it's good to be able to confirm that you have a good ground the whole ways down to the ground. It's going to be important. It's going to be your safety. It's going to be what makes sure that your breakers go off when they're supposed to, that you have a good ground. And of course, if you're doing live testing, you want to make sure you have a good ground before you start touching stuff. So, and the other problem is the category and voltage ratings on some of these are not very high because they're usually, a lot of the cheaper ones are made for 240 volt systems. So if you're testing a 600 volt DC system, it's not exactly appropriate. The two that I have seen is the Fluke 1587. I like because it's actually a meter too, so it has some meter functions in it, but it also does the insulation resistance testing. That's really nice. The specs are actually very similar to the Mager brand, which is the one that Solmetric sells also. And Mager's kind of the Kleenex brand. That's the one everybody associates with it because they were the first ones to have Magers. They also charge a little more for it, but specs are pretty much the same, so you can do it with either one. Again, the issue with this is that it's really not as safe to test a string in a module with this. I mean, you can do it. There are some module manufacturers that don't like you to do it, so you have to be a little bit careful about that. And again, you know, the problem we just talked about earlier, that voltage is going to add, and if there's a short in the system actually that you're looking for when you're doing an installation test, you could possibly damage some of the components. And the other thing to bring up with installation resistance is it's not always the same. It's kind of a moving target. It's very dependent on the temperature and on the humidity when you do the testing. So a lot of times people use installation resistance testers to track down a fault. There's a ground fault, the inverter keeps on clicking off, and they try to find out where it is. And that's a good tool to try to track that down, but sometimes it's only faulting like when it rains or when it's really high humidity, so you actually have to sprinkle down the system to try to find where the short is, which isn't that much fun to do. But it is very dependent on that. So you don't get like a solid number and you go, oh, this number is great, everything's good. You get kind of a range of numbers. So a lot of times it's kind of a comparison. If you have multiple strings, they should all come out about the same under the same conditions. If you got one that stands out, then you know you got a problem. But if you go back next time and test them, the numbers won't be the same again. So the IEC has kind of a very slack standard. They say that if it's 120 volt or less system voltage, you test it at 250 volts, which I think is a good recommendation. I've read in RE wrenches where people are saying, well, my Mager goes up to 10,000 volts. I'll just make it to 10,000. That should be okay, right? Don't forget that the system's rated at 600 volts DC, so you want to be a little careful about pushing that too high. But they say basically that it has to have at least a half ohm or greater resistance. And oftentimes a wire will come out in the giga ohms. So that's actually a really good table as a recommendation. I don't think you have to test modules as high, much higher than what the rated voltage is. And of course, if you've got a big system with a lot of combiners going on, it's pretty easy with all these tools to make a connection to your negative and to your positive bus and just put down each one of your strings, fuses, one at a time and do your tests. So you can do actually very large systems, you can test them very quickly with all these tools. So now we get into the fun tools. The combination tools, these are the ones that were made in Europe to do all of the IEC required tests. And they're really nice because basically the ground continuity is a separate test, but the polarity, the open circuit voltage, the short circuit voltage, and the insulation resistance is all done automatically by the press of a button. So you make all your wiring connections with a tool, you hit a button, and it does all the tests for you all at once. And it saves it to a file, and then you can download that file as part of your documentation of your commissioning. So you can see in this is actually the C word, which is this unit right here. And what it looks like when it's live. RPE is the protective earth. That's what they call it in Europe. It's the resistance of protective earth, and it says what the ohms were. And of course, you want a pretty low number on that one. And usually, there's no limit on it based on the IEC, but usually I look at the size wires that you're using and the number of connections you have, and you can kind of estimate what the resistance in that wire should be. And as long as you're close to that number, then things are looking pretty good. I guess you could be really, really picky and actually calculate all of your connectors too, but that seems to be a little too much for me. It gives you your short circuit or open circuit voltage. That's this one right here. It does your short circuit current, and then it gives you the ohms on your resistance test, all in one step. And the nice thing is when it does a short circuit, it has a nice switch internally that doesn't arc and doesn't have problems with it faulting. And also when it's doing the megging, it's actually shorting out the 2 leads, which I think is a better procedure, safer for the modules to do it that way. And the other nice thing is that these guys can do irradiance and temperature automatically. It's put into the data file, so you can make adjustments. If your conditions weren't the same as STC, which they usually never are, you can make those adjustments. They've got large memory, so you can do quite a lot before you have to download it into your file and do your report, and it's downloadable to PC. Some are better than the others. The C-Word has a nice file that you can put right into Excel, so it's very easy to fit into your own report style. The Hexaflux one, when we look at that one basically, they give you a report, and that's what you get. So if you want to do something else with it, if you want to calculate, your values back to STC values so you can compare to the module manufacturer, it's a lot harder to do. So the C-Word, that's this guy right here. You guys can come up and take a look at this stuff afterwards too. It comes with, it's about $1,600, and it comes with an irradiance meter and a temperature probe that you can put onto the cells, and it's radio controlled. So it sends that information back to the meter that you can just do the test right like down in the combiner box at the array. And it also has an optional clamp on so that you can actually do the kilowatts of DC going into the system. The one thing that's a little limited on the C-Word is that it will only do the test if it sees voltage. So it can't do the insulation resistance test on a wire because it won't see voltage. It was designed to do that because it was designed to test the module, and that's the way that was the way they designed it. So that's a little bit of a shortcoming in my opinion, because then if you have to do any insulation resistance testing of wires, you're going to have to buy an additional megger to go with it. Now the other one, so basically you put your sensor up by the module, you get your temperature readings, that's radioed back to this guy, and then you can see the sensor just taped on the back of the module here, the temperature sensor, and then basically you just plug into your string. This is a single string here, so I plug directly into it, and you can get your whole test done right there. You can do ground continuity, and then you can go ahead and do the final test. It's just one button, does the whole test. So it's really quick. I mean, and that's not a bad price point, I think, for getting the irradiance meter and getting the temperature probe and everything together with it. And the other thing that it does, one of the criteria in IEC is that all strings should be within plus or minus 5%, which I think is kind of a wanky requirement, because if you're testing a lot of strings, you may not have them within plus or minus 5%, because the weather's changing on you dramatically. And a lot of times when you're commissioning, you don't have perfect weather conditions. So what I usually do is I convert it back to standard test conditions so I can do a apples and apples comparison and everything. And then I look at what the manufacturer specifications are, plus or minus 3%, and that's what I expect it to be at. And you can take into account, if you're doing multiple tests annually, what the degradation of the module should be to meet the warranty. You can take that all into account too when you do that. But the nice thing is you can put it in a spreadsheet and you can do this fairly automatically. And actually this one is the kilowatt hours, and you can see watts per meter at top, pretty low, 204 watts per meter. Not a very sunny day. Tells you what the open circuit voltage is. Actually, this is operational voltage, excuse me. This is what the array is operating at, and it's putting out 2.4 amps, which ends up being 0.87 kilowatts. Which, this is a 2400 watt array. That's pretty low. But there's only 200 watts of irradiance, so. And actually, most of these meters, when the irradiance drops below 100 watts per meter squared, they won't even take a recording. Most of the time for commissioning, they recommend like 800 to 1200 watts per meter squared. You know, they want you to do the testing in the middle of the day. Now the other brand is a Huxaflux. It basically does the same stuff. It's a little more complicated to learn. It costs almost twice as much, but it is more flexible. You can do one button testing or you can do single button testing. And it also allows you to meg off-grid systems. So you could go to the charge controller and you could connect to the wiring coming down from your array, even if it's series and parallel wired. You can't do the short circuit current because it's only got a 10 amp rating, but it'll do megging individually of each side of the array and do it automatically, which is really kind of sweet. They have their own little software package. It's really hard to manipulate the numbers into your own report. You're kind of stuck with the way they do their report, so that's one kind of a down draw. But the other thing I like about them is they actually have the irradiance meter is a separate piece, and then they have a communications piece that actually does radio control back to the unit. But it can also be plugged in directly with a USB if you have trouble with the radio, and it can also be put into record mode. So it'll record it, and then when you put the two pieces together, it puts all the data together. So it kind of syncs up between the two. So there's a little more flexibility. This guy, you got radio control, and that's all you got. So if for some reason you have radio interference, this one isn't going to be as robust. And the other nice thing is their curve tracer uses the exact same irradiance meter and radio. So if you do buy up to a curve tracer some point down the line, you don't have to buy those two pieces. So you save a little bit of money when you buy up. So now let's talk about curve tracers. So like I said before, basically if you have the ISC, the VOC, and the VMP, the operating point, or the knee of the curve, if you have those 3 points, you should be able to tell if everything's okay with your modules. What the curve tracer does is it gives you more information about what's going on. So for troubleshooting, it can be a lot better. So here's your normal curve in red. And you can see if your irradiance is lower, then that's going to drop the top of your curve. Your ISC is going to change. If your temperature is different, if it's hotter temperature, your VOC is going to drop. So you can calculate those out by hand. If you have that data, the irradiance and the temperature, you can calculate that out easily. You don't really need a curve tracer to do that. If you have shading issues or you have bad cells, you get these bumps in the curve that are indicative that the diodes are firing for some reason. It might be because it's shaded or it might be because you have a bad cell. So, I mean, if you're troubleshooting, they're a handy tool, but I don't think you really necessarily need to have them for commissioning. Basically, it's using the output of the module, and it has either a resistor or a capacitance bank that they use as a load, and they adjust the load. So they try to get all those operational points by adjusting the load. And that is one difference between some of the curve tracers use resistor banks, so they're prone to get overheated. If you're doing a really big system, that can be a problem. I've never had a problem. The one that I have is like that, and I've never had a problem with it here. But I can imagine if you're doing a megawatt plant in Arizona in the middle of summer, that might be an issue. It doesn't hurt anything. You just have to stop and let it cool down before you can take more measurements. So like the Solmetric model has capacitors, so it doesn't have a problem with overheating with the capacitors near as much as the resistors. Oh, it's like all of these tools. There's no perfect tool. I keep on telling them what I want, and I don't always get it. So especially with the curve tracers, I mean, there's a wide variety, and they all have advantages and disadvantages. No, they usually go one way or the other. Oh, which one do I like better? It's very hard to tell which one's better. They're all kind of a mix. So actually, I like the Solmetric a lot. but there are some disadvantages of that one too. So they have a 600 volt DC model, and they have a 1,000 volt DC model now that actually goes up to 20 amps, which it's the only one that goes to 20 amps. Some of them are 10 amps, some of them will do 15 now. As we're getting into higher power modules, that's going to become an issue. So as buying a tool for the future, 20 amp would be a better choice, I think. They just came out with that 20 amp model. I think their software is absolutely excellent. It's Excel based. You can get into it. You can move stuff around if you need to. They really did a good job, by far better than any of the other curve tracer companies. They did the best job of making it very user friendly in terms of being able to handle the data. And thank goodness, American company. They got good service. They got really good techs. They know their product. Some of the other companies coming from Europe, they have representatives who are selling their product in the U.S. that they don't turn any wrenches, so they don't know when you call them up with questions from the field, they just don't understand what's going on. I have to get hold of Italy. Italy will help me with this one. That's usually the response I get from Huxaflux. Disadvantage. You have to have a PC to take the measurement. It uses a radio control on your PC that it talks to the load bank and it talks to the irradiance meter, and they all talk together, and then it dumps it into the spreadsheet. So that means an extra piece of equipment to carry around. Not so bad. Again, the capacitors means there's not going to be as much overheating. It's heavy, and it's got 3 pieces that are pretty big and bulky. I'd say the learning curve on it is not too bad. It's about a medium learning curve. Unfortunately, I don't have one here to show you, so we'll just have to do pictures. So this is their irradiance meter and temperature meter. They made a nice bracket where it fits right on the edge of the module, which is real convenient, as long as you have a framed module. Otherwise, it doesn't work so good. And then basically, you plug in the capacitor bank unit directly into your string, and then you could stand anywhere with your laptop and do your measurements. And one thing they've done new with this new radio receiver is that this is all a mesh network. So it can communicate in any direction in any part of the triangle. So it helps it a lot when you might have radio wave communication problems with it. And I think they quite improved. I think they got a 300-yard radio limit on that now, which they upped it quite a bit. I think it was only 100 yards before. And like I said, the output, they have a lot of histograms. You can set your values of what your limits should be based on your manufacturer's specification and the age of the modules, and then it'll actually give you a yellow block when it doesn't meet the specification. It'll let you know right away when it doesn't meet the spec. And it's in a spreadsheet. So I mean, you can actually download it and manipulate it a different way if you want to do it in a report or something. So you have access to all the data. Some of the other units, you don't have access to the data. You just get their output. Now, Huxaflux. It's actually made in Italy, but it's actually I think it's a Danish company. So I'm probably not saying it in the proper Danish pronunciation, I'm sure. They have 2 models. They have a lower model that just does curve tracing, and then the model that I have up here is a model that will also do power performance, AC in, DC in, AC out of the inverter, one channel, which is really an added feature. It's all in one piece. It's a lot lighter. It's got a lot more flexibility. There's a lot of things you can adjust when you do the test, which means, of course, there's a lot of things you can screw up when you do the test. So sometimes having more flexibility means a much bigger learning curve, and it definitely has a bigger learning curve. The nice thing is their whole product line, everything works together. Everything uses the same sensors. So, I mean, if you're really doing a lot of testing, it might make sense to go with their product because they're all integrated. They all kind of operate the same. So once you've learned how to operate one, it's going to be very similar with another one. And they all use the same sensor set. So that can save you a lot of money if you're buying more. They have PV analyzers for 3-phase in, 3-phase out, 3 DC channels. And actually, the one that I have, you can buy an adapter that allows you to do 3 DC channels in and to do 3-phase out of the inverter. So it does have a lot of flexibility, and there's a lot of things that they thought about in terms of that. But the learning curve is a lot harder than any of the other ones. So basically, you put your irradiance meter up on the side of the module. You put your temperature on the back of the module with a piece of tape. You put your radio control near all that because everything gets plugged into the back of your radio control. And then you can go wherever you want with the meter itself, and you plug it into the output string, and you can get your curve trace from that. The nice thing is, once you have your criteria in there, it'll give you a go, no-go on the module, and it'll say, is this within the specification of the module, or the specification that you give if you're doing it several years down the road where you might be adding in the degradation of the module over time. It'll give you that number right away. So you get an instant feedback in the field of the results. It'll also give you your curve trace, and it'll give you your power trace. And that's all on the screen on board, so you don't need a separate computer to do this. Then you can download it into their software, and you can make a report out of it. And the one I have allows me to do AC in, or DC in, AC out, all in one measurement. So this is an interesting one. It's a 2400 watt array. It's an iTech array. And it is the wonderful Exeltech inverter that everyone loves. It's actually one of 2 that are still working in Washington State on my house. Maybe it's because I AC coupled it to my Outback. I don't know. The only 2 that I know that are working right now are AC coupled to Outback. So it's kind of an interesting point. Anyways, if we look at it, nominal is 2400. Gives us our cell temperature and the temperature of the air. And so it actually calculates the power that's coming out of the array based on the voltage and the current. And it tells you what the voltage and the current is, and then it gives you an efficiency number of the array, 0.89. That sounds pretty bad, doesn't it? And we're at 949 watts per meter squared. We're almost 1,000 watts per meter squared. So when we look at the output of the inverter, we've got the inverter is totally pegged. It's supposed to be an 1800 watt inverter, and it's 1.88. So it's totally pegged out. It tells you what the voltage of the AC is, and it tells you what the current coming out of it is, and it gives you an efficiency of 0.92, which is kind of low for that inverter, right? Anybody know why there's such a discrepancy here? It is 949 watts per meter squared. And it's actually not that hot. It's 36 C, so that has some impact, but not enough. That inverter should be around 0.96, 0.97 efficiency. It's 40 C. It's a hot day. It was middle of summer when I took this reading. It wants to do more, right? I mean, it's a 2400 watt array. It probably would do pretty close to 2400 watts under these conditions. It's got full sun. It's a little bit warm, so it's probably going to be a little bit low because of that. But because this inverter can only process 1800 watts, basically the inverter is cutting back. It's throttling back on the current, which is forcing the module to not be at its optimum. That's why it has a low, it's at the wrong part of the curve operating. So it has a lower efficiency than if it was at the knee of the curve. And it's being held there because the inverter is purposely dropping the current, and it's drawing down the array current. So actually it's doing exactly what it's supposed to be doing. And actually this is interesting too, because this array is about 37, almost 40% larger than the capacity of the inverter. It actually, I measured this on the day, and I basically had almost 20 sun hours. I mean, I basically was pegged on the inverter for 20 20 sun hours of the day. I mean, I got 20 kilowatt hours out of this inverter in one day over in Wenatchee with a tracker. So as soon as the sun hit in the morning with a tracker, it basically hit 1,800 watts, and it stayed at between 18 and almost 1,900 all day long. So I know a lot of people don't like to oversize their arrays because they're afraid it might hurt the inverter, but the inverter operated just fine all day long. It basically just throttled back on the current. Yes? Yeah, that's probably because this is probably because of the fact that it's a lot harder to make sure that you get everything in there right when you take measurements, and that was probably like operator error, I would guess, because that would be very surprising. Now, the interesting one I have a sample of today is the Trica curve tracer, and it's really a pretty sweet little unit. It's much smaller. It's got the sexiest module clamp of all. They really did a good job on that. And it comes in a really, really, really nice case with all the parts that you need. It's actually about the same price as the Solmetric. And actually, there's a misnote on there. It's actually 15 amps rated, so it's a little bit higher rated too. Really easy to use. It has radio communications only, and but the software, the way it handles and processes the data, you're kind of stuck with what they give you. But in most cases, you know, depending on what you need, that might be more than adequate. I know I just did a training for APS, Arizona Public Service, and they were training their O&M operators for their big megawatt plants. They've got like 6 new megawatt plants in Arizona, in the Phoenix area. And this is the one that they chose because it's small, compact. They can throw it in the truck, and they can do a test pretty quick out in the field. They don't need to have all the bells and whistles. They just need to know that it's not right. And that's enough for them to know that they got to go and do more troubleshooting on that string. Yeah, basically it just clamps on. The one thing that's different with this, it doesn't have a temperature sensor. It actually has a little IR piece on the top, and you have to physically take temperature measurements. So that is one drawback, because you need to do that fairly frequently to make sure you get good data, because the temperature can change pretty dramatically in the course of a day. So not having the automatic temperature measurement that's the biggest drawback I see with this one. But it is small and compact, and you can see here they're doing it. Actually, these are old 300-watt modules that were originally in the Star Center, I think it was called. They did a lot of PV testing in Arizona early on. Those modules look really bad. They've got corrosion, they've got delamination, and they're only about 15 years old. They look really bad. And actually, we had problems with megging them because they were all so bad that they were all megging bad. So it was really hard to get a comparison with them. So it's nice and small and compact. And we don't need to read all that. And then the last one we're going to look at is the infrared cameras. And there's a wide variety of cameras out there. Actually, you can get them for under $1,000, but I don't think it's worth it to buy one for under $1,000. The one that I have has dropped in price considerably. I think I paid $2,500 for it, and I'd say that you got to get into the $2,000 range before it's going to be really useful if you're going to be taking temperature comparisons on cells on a module. A lot of it has to do with the resolution, number of pixels, and a lot of the adjustments that you need to make. A big problem with infrared cameras is there's a big learning curve in infrared cameras. And if you're going to invest in anything but the simplest kind to just take spot measurements, you're going to have to invest in some training. It's kind of like going to the doctors, and he reads your x-ray and he goes, okay, here's where your broken bone is, and he shows it to you, and you go, okay, I'm glad you see it because I don't. You know, it's kind of like that. There's a lot of things that you can do that gives you bad data. And especially if you're going to be using that data for warranty or commissioning, you have to have a higher-end piece of equipment to do that. The latest I heard now is that they're mounting infrared cameras on drones, and they're flying them over the array fields taking pictures of the modules to see if any of the cells are going bad or anything. So yeah, 2500 is about where you want to be if you're really going to use it for testing. Anything other than just spot measurements. Then you might as well just get the little one spot infrared camera and do it that way. So the nice thing on the better cameras is that you can do a lot of these spot measurements, and you can actually do area measurements, so you can actually tell what the exact temperature is in each one of those zones. This is a module that was underperforming quite a bit, and basically what I surmised is that they had cells that weren't matched with the other cells in the module. So we had cells that were lower power ratings, so they were dissipating a lot more energy from the rest of the cell. And I just want to say something about safety, mostly because this type of testing is done on live circuits. So this isn't a game, and you really need to have safety gloves. You really got to know the equipment that you're using. I mean, there's a very high shock hazard. There's a very high arc fault hazard also. And one of the big things with all of these tools is, especially now that, code is allowing 1,000-volt DC systems, is we need to have equipment that's rated appropriately for working around this equipment. And I don't know if anyone's familiar with the different ratings. They have like a Cat 4 rating is coming directly from the grid down to the power box, and a Cat 3 basically it's got some isolation somewhere in the system, so it's a lot less arc fault potential basically. And in general, the tools that you buy for working on systems now, they should be a Cat 3 1,000 volts, Cat 4 600 volts. Like most of the fluke meters are that. That's pretty standard, I think, with most of the fluke meters now. This is a case where someone took a reading of a 600 volt DC array with a Walmart special meter that didn't have the rating, and it arc faulted and blew up in his hand, and he had major burns on his hand from operating it. Actually, if you go on the Fluke website, they've got a great app page on this whole thing about using the right equipment and the right equipment when you're doing tests like this. That's it. I just want to mention that Solar Energy International, I teach for them on a contract basis, and they have a 351 lab. If you're going to buy any of this equipment, I highly recommend that you send somebody down there and take that lab, because they have all the different tools, and you get to try all the different tools in their lab yard and decide which one is the one that you want to buy. Unfortunately, when I bought most of mine, there wasn't much on the market, and there wasn't a 351 class. And so, it was much harder to decide which ones to buy, and I probably would have made a different decision if I had a chance to play with all of them first. So I think if you're going to invest thousands of dollars in these tools, it really makes sense to go somewhere where you can play with all of them first and compare them and see which ones you like, because they're all a little bit different. None of them are perfect. When a perfect one comes out, I'll let you know, but there hasn't been one yet. And then, of course, you could contact me. I do training. I did training for Northwest Wind and Sun a year ago, and I also I do the training, the 351 training, so I have experience with the other tools too, plus all the other consulting that I do. I'm trying to move my business more into doing third-party commissioning now for the bigger systems. Any questions? I think he's going to want you to talk into mics for the people that are on the web.
So these systems are a lot for string inverters. I noticed you're checking the AC side, but we're doing a lot of micro inverters and stuff. And I think the one thing that made the industry so much better is, I don't know who decided to do it, but the audible click. I think it's only within the last 7 years that when you click a module together, you hear it now, and before we never had that. And so I think that was a really good thing to help things go. But I guess my question is so we do a lot of microprocessor or micro inverters. So how does these tools help us with that?
Well, I did a microinverter system that I commissioned, a project that was done about a year and a half ago. And, you could test each individual module very quickly with one of these combination testers to make sure the module is good before you put it up on the roof. I think that's really helpful. And then basically I just did a performance test at the AC connection to see what the inverters were putting out. So if I had the irradiance and the temperature of the module, one module in that string of microinverters, I can predict what the inverter should be putting out under those conditions and verify. So that's basically the way we did it with that. You could do each one individually, AC and DC, but that would be a lot of work.
Thanks for the presentation. I think it was very helpful. I was wondering, when you were at the Star Center, did they mention what they thought the delamination issues and other fault conditions that had occurred to the panels? What had been some of the principal causes?
These are very early modules, big 300-watt modules that ASE made in the very beginning, and I think they were probably like first-run prototypes. So I don't think they didn't have it all figured out yet. There was some very strange things about the modules too, the way they were internally wired. It was, but yeah, I didn't put any in this presentation, but I probably should have. It would have been interesting to look at some of the there was a lot of delaminations around the junction boxes, so they probably didn't have a good seal, or they didn't pot where the penetrations through the back sheet were. And actually, these were glass-on-glass modules too, so they weren't Tedlar back sheets. But I mean, if they didn't, do their process properly, that's probably where the delaminations were coming from. So they're very early on prototypes.
Have you found any of these to be better at testing down at the inverter rather than up on the roof, especially like going back and recommissioning after the fact? Sometimes it's pretty hard to get to the combiner at times. It's like you have one person, or just doing a test down at the inverter, because a lot of these are more European style where you're doing just MC4 connections, because most of the times Europeans are bringing the MC4s right in the bottom of their inverter.
Right, and that's what they're designed for. So finally they're starting to make some modifications where you can add a clamp on, so you can actually go in a combiner box or into an inverter and do the test through that. Sometimes it's challenging, but most of the time I do try to do them at the inverter. That's usually the easiest place to do it, or where the combiner box is. The only one that's kind of tricky is the ground continuity, and basically I have a really long cord that I zero out on the continuity tester, and I have somebody up on the roof with a clamp running down, clamping modules, clamping rails at a couple different spots so we can make sure that we got continuity through the whole system. So that's the only one you really have to be in the roof for. And that one I normally like to do down to my ground connection if I can. Can't always do it. Sometimes you have to do it in sections.
Yeah. Hi, Bill. This is great. You said commissioning is not required, but it is in Europe. First question, why do you think that is, and do you think it will be required?
It is being required for large projects. That's where the requirement's really coming from, and that's what's kind of driving the market right now. And that's why these tools are coming over here, because of that. And, of course, that's because the bank says you will do it. And I will pay you to do curve tracing of every string because I want to know that I got what I paid for. And I want to know the condition of it year after year so that I can, go back to the module manufacturer and get replacements before I start losing money.
I just wanted to mention that if you're working on a LEED project and you need to get LEED certification, commissioning is a requirement on those projects.
Actually, Kevin, you have some experience with that, right? The Bullet Foundation building? It's actually commissioning is common for most large building projects. I mean, there will be an electrical commissioning that'll go through. There'll be HVAC. Yep. Every system will be tested, and often that is done by a third party, especially when it's a LEED. I think LEED requires often third party. You can't inspect yourself. Say, yep, everything's good. Inverter green light came on. Everything's good. We can go home now. Any other questions? So all these toys are up here if you want to come up and look at them. Yep.
If I wanted to go to the school and do the lab, What qualifications would I need to have to do that?
I recommend that you have some experience installing because it's an advanced course, so they're going to expect that you have some wiring knowledge and that you have some knowledge of how systems go together. There's a great troubleshooting lab where they actually do some faults in combiner boxes and stuff. So, and actually, I've seen every person that's ever done the lab when I was in it always pull an arc. Because they don't check current with their clamp on before they pull the wires out. They say, oh, I know what the problem is. This is miswired. And they start pulling wires, and all of a sudden they have an arc. Of course, we make sure it isn't that powerful of a string when we wire it up. And that they have their safety gloves on and their shield on. So, because we know they're going to do it every time. And these are usually experienced installers. I mean, there was just a blog on RE Wrenches, which is kind of a blog for installers, where somebody said, oh yeah, I had this problem and I pulled the wire off and there was a little spark, and there was a spark when I put the wire back. And I mean, boy, he got hit with a barrage from all the other installers. What are you doing pulling the wire without checking the current first? That's a pretty basic rule. Any other questions?
Well, I'm a homeowner with a solar system on my roof that works very well. Put on by West Seattle Natural Energy. And my question is, has anybody had any experience using ballast instead of mounts that you glue on a commercial roof, and what kind of results have your customers gotten?
Anybody here have experience with ballast? I don't think there's that many ballast systems in Washington. Do you, Josh?
So we've done several all over Washington State. You can get total dead loads down 3.5 pounds a square foot, as high as 8 pounds, depending on how tall the building is. The thing here in Washington, though, is we're in a seismic area, so you can't truly do ballasted systems. You always have to have a few tie-down points and actual penetrations into the roof. So they're kind of a hybrid system here, where you can minimize the penetrations down to, as low as 4 to 10 penetrations, but you're always going to have some combination of ballast and penetrations with them. So, but they work great. We've done loads of projects with them, and it's kind of how all large commercial flat top systems are done these days. So.
Yeah, the one problem that some ballast systems have had is that there is always a little bit of movement, and they can start working their way into the roof a little bit. So a lot of it depends on the design of the ballast, and actually it helps a lot to have it a couple anchor points where you're kind of tying it in so it can't move as much. But that's some of the older ballast systems. They've noticed that they're starting to work their way through the membrane because they do move a little bit when it's windy. So a lot of newer ones now, they're putting pads down underneath, protecting pads and stuff to put barriers between.
And when you order them from the factory, not all of them come with the pads, and so that's something to watch. Some of them, they just expect you to provide that after the fact, and a lot of people don't realize that they're just laying metal right on the membrane roof. And it's an added expense that you might not expect, and you kind of catches you last minute. So definitely watch out if you're looking at two systems in their same price, whether it has the padding included or not.
Anybody else? All right. Is there anything after me besides beer?
So really quick before everybody starts playing with toys, after today we are moving our meetings to the Finney Neighborhood Center, not the Finney Market where we're drinking, but the Finney Neighborhood Center, very close by, and they will be held on the first Wednesdays of the odd number months. So July 2nd would be the next one, which is a Wednesday, and I know it's right before the holiday, so hopefully most people can make it. But that's where the new meeting place will be, and there should be refreshments at the new place, unlike here.
So a quick thing to add, one of the things we're going to try to start doing as an organization is reaching out to our members a lot more. So we're going to start sending a lot more surveys. Like recently we sent out a survey to figure out where the best place to hold these meetings would be. That's how we picked Finney. So I really encourage all of you to check your email, look for our surveys, vote, just so you can have a voice in the organization a little bit more. We're also going to be reaching out a lot more for volunteers to help us do Solar 101s or to help us put together a slideshow or a staff booth at the upcoming, what is it, the Mother Earth News Fair? May 31st. And if anybody volunteers to go do that for us, I will personally give them some salmon when I get back from Alaska. So just a little, little nudge there. I'll do it. So I got plenty of it. The other thing, too, is that given all these efforts, we're really trying to, as an organization, raise the amount of education in Washington State on solar, because we've noticed that one of the bars to, one of the things that installers, I used to work as an installer, and one of the things that installers run into, I think, quite often is just a lack of education on solar. People don't know about the tax credits. They don't know about the utility advantages, all this stuff. And so we're trying to kind of eliminate some of that barrier by providing free education. And so the reason I'm saying this is because I really hope that you guys will renew your memberships with us, support us, come out and volunteer and everything, because it really helps all of us in this effort, essentially. So, and yeah, we are drinking at Finney, so that's the other thing. So that's the last time I'm going to do that. So thank you.